Okay, let's take a look at a few of these formula sheets. So the formula sheets, which look like this, sometimes there's a few per chapter, sometimes there's only one. A little bit about those. So we have a couple of pages per each chapter, and then like one final page or two or three for the whole year. So when I put something up like this, it means that these words are going to be incredibly important. So left and right, up and down, obviously the simple ones, and then vertical, which is up and down, and then horizontal, which is sort of left and right, but vertical would be a vertical line like standing up, and horizontal would be a horizontal line like lying down. And we're going to be talking about the words translation, which is moving left, right, up and down. And then we're going to be talking about transformations, which can be compressions, which would be compressing either vertically or horizontally, or expansions vertically or horizontally. And we're also going to talk about reflections. So we're going to talk about vertical reflections, and we're going to talk about horizontal reflections. And we're going to be doing it using formulas and different types of notation and English sentences. So we're going to see graphs like y equals x squared, and we're going to see that graph go up 1, and the equation's going to be x squared plus 1. We're going to see a little bit more into theory and a little bit later into the notes where these equations come from, and then we can go down 2 by having a minus 2 over here, and right 1 when we have an x minus 1 inside the brackets, and left 2 we have an x plus 2 inside the brackets. And if we put a 2 in front of x squared, we multiply the y values by 2. And if we put a 1/2 in front of x squared, we multiply all the y values by a half. And if we put 1/2 x in for x, then we horizontally expand it. Odd, isn't that? Definitely watch the theory and see what happens, when and why and how things happen. And then if I put 2x in for x, it's actually a horizontal compression. Again, counterintuitive. And then we can take other functions and we can do vertical reflections by putting a negative in front, or horizontal reflections by substituting negative x in for x, and then we can do both, for example. So we always start with a simple equation like this. Now, I downplay things sometimes. First of all, k may be on this side, and we're just going to subtract k from both sides. Subtract k from both sides and put it over on this side. Most people like it over on that side. Again, watch the theory as to why it was on the left side and how it got to the right side. But let's start with k. So k, we do vertical up and down translations based on what k is. So if it's x squared plus 2, x squared goes up 2, and if it's x squared minus 4, it goes down 4. Let's talk about this a out in front. Well, if a is less than 0, like negative, it's a vertical reflection. And if the absolute value of a is greater than 1, for example, 2, then it's a vertical expansion. If a is between 0 and 1, then it's a vertical compression. Now let's take a look at this h first of all. So remember from quadratics, if you add something inside the brackets, we do the opposite of what's inside the brackets. So we do horizontal translations left and right. And if it says x plus 2, we go to the left 2. And if it says x minus 4, we go to the right 4. And this b value, a little bit more complicated. So if you kind of understand an interesting counterintuitive thing, where if we have x plus 2 inside the brackets, it goes left 2. Well, if I have a b value less than 0, it's a horizontal reflection. So if it's negative, it's a horizontal reflection. And if b is greater than 1, like 2, this time it's a horizontal compression of 1 over b, or 1 over 2. So again, we're going to do the opposite of what we see inside the brackets with respect to h, left and right, and the reciprocal of what we see inside the brackets with respect to b. So down below is a whole bunch of examples of what all the different letters can be. And if a is something like 2, that means it's a vertical expansion of 2, multiplying the y values by 2, or simply writing it in mapping notation, whereby we just say what we're going to do. And we have examples of each and every single letter and what that would do as short notation, all sorts of things: expansions, compressions, reflections, horizontal reflections, vertical etc. And each and every exact English sentence as to what to do according to that letter. Again, from the theory, we want to simplify it all, and we want to remember that if we have a simple equation and we substitute the opposite operation for the variable and we do the necessary algebra to go to any form that we like, whether or not at the top k is on the left-hand side, if you like k on the left-hand side, or if you want to do algebra to move k over to the right-hand side. Other things we're going to take a look at this chapter, or we're going to take a look at the inverse. The inverse, where we switch x and y. And it happens to be a reflection over the xy axis, a diagonal check. A little bit of ways that we can check if the inverse is true. We'll see that later in the notes. And we'll talk a little bit about invariant points. So, for example, invariant points, points that don't change, points that stay the same. So, for example, if I do a horizontal reflection, then my y-intercept stays where it is and it does not change. If I spin on a dime, I am not actually changing where I am in 3 space. So if I have a vertical reflection, that means my x-intercepts don't change. And for example, inverses, anytime you have the same x and y value and you switch x and y, those points don't change. For square roots, anytime we have a y value of 0, because the square root of 0 is 0, and anytime we have a y value of 1, because the square root of 1 is 1, those points don't change. And we work with simple rational functions. Anytime a y value is 1 or negative 1, because 1 divided by 1 is 1, and because 1 divided by negative 1 is negative 1, that means that invariant points on simple rational functions will fall on the line y equals 1 and negative 1. But back to the point, transformations, moving graphs up and down and left and right, and doing expansions and compressions and reflections. And most of the time we're going to be taking a look at equations. So we'll want to do a vertical translation up 3. So a vertical translation up 3. Well, again, go through the notes before the theory. The theory is for the test to get very hyped as remembering what we do to things and why very fast. So if y is equal to x squared and I want to make that graph go up 3, I'm simply going to put y minus 3, substituting the opposite operation for the variable. Possibly adding 3 to both sides of the equation to see if you like that form better. But again, if I want to do a vertical translation up 3, I want to go up 3, I want to add 3 to all the y values, I simply substitute the opposite operation for the variable, and I put y minus 3 in for y. And again, if you want to add 3 to both sides, if you feel better with the 3 on the right-hand side, feel free to do so. So now, again, what I mentioned before, one method, substituting the opposite operation for the variable. Some people lazily just put the plus 3 off to the right. and go, oh, well, that makes it go up 3. And I think, oh my gosh, I can't imagine how complicated you look at math. You must think about 100 different ways to do the same thing. And I just remember one way to do all of the different things. Always substituting the opposite operation for the variable. So if I want to do a horizontal translation right 3, I simply just put x minus 3 in for x. Then, if I want to go up 3, I just put y minus 3 in for y. And if I want to add 3 to the x values and go right 3, I just put x minus 3 in for x. Therefore, anytime I want to either add 3 to the y values or add 3 to the x values, I either simply put y minus 3 in for y to make it go up 3, or I put x minus 3 in for x to make it go right 3. And I have only learned how to do one thing and substitute the opposite operation for the variable. So a whole bunch more different examples with each of all of their substitutions and the different equation and the exact method as to what to do. And noticing we always just substitute the opposite operation for the variable. At the bottom there's an equation, x squared plus y squared is equal to 4. And I ask people, how do I make that go up 3? And after all of that at the beginning, making the graph go up 3, simply putting y minus 3 in for y. And that will make that interesting looking graph go up 3. It is a circle, but you don't need to know that. And if you learn how to do things properly, then you have to learn how to do one thing. And if you only know how to do the other, then you have to do complicated math, like subtracting y squared from both sides and subtracting x squared from both sides, square rooting both sides, or remembering plus minus, getting the equation into y equals, and then simply putting a y plus 3 off to the right. I can't imagine how complicated that must sound. If you follow the instructions and remember how to do math foundationally and remember simple methods that you do all the time that vary, substitute the opposite operation for the variable. If I want to multiply all the y values by 2, I simply put 1/2 y in for y. If I want to horizontally compress the graph and I want to divide all the x values by 2 or multiply all the x values by 1/2, I simply substitute 2x in for x. Substitute the opposite operation for the variable. Feel free to take a look at all of the different examples and really understand why I put these words on. We want to get very, very familiar with these words. We want to get very familiar with basic graphs and what they look like and what different things happen to them when different attributes change. Very familiar with our general form and what each and every one of the different letters does, and all of the basic English instructions as to what we do to letters, because notice we are still adding, subtracting, multiplying, and dividing. And simply substituting the opposite operation for the variable. I am trying to be annoying. I'm trying to make sure that when you're in the test and you're sitting there and they tell you to expand the graph by 2 in the horizontal x direction, and you're thinking, okay, horizontally expanded by 2, horizontally expanded by 2. Okay, math is hard. Okay, what do I want to do? I want to horizontally expand it by 2. What am I trying to do? Well, horizontally. Okay, what's that? That's x. Okay, I want to expand it. Well, I must be multiplying by 2. Okay, Nick taught me to substitute the opposite operation for the variable. If I want to expand it by 2 and multiply all the y values by 2, I simply substitute the opposite operation for the variable. And if I want to multiply all the x values by 2, I simply substitute 1/2 x in for x.